8-6, parts of similar triangles. Our very last unit, our very last section of Unit 8. Okay. So we have 4 theorems, and we're going to math with 2 of them. All right. So we've got theorem 1, 2, 3, 4. It's going to take us longer actually to talk about the 4 theorems than it is to really do the math. Well, let's check these out. So we have got, if 2 triangles are similar, okay, the lengths of the corresponding altitude are proportional to the length of the corresponding sides. Your altitude is the line. It's either inside or outside of a shape, okay, triangle, I should say, and it makes a right angle. So sometimes it will go from a vertices and it'll make a right angle inside, but sometimes you'll see these altitudes outside of our triangles as well, and they make a right angle, and we do that so we can use all of our skills that we learned specifically with right triangles. Okay, but for this, they're proportional and they're proportional to the side. Theorem 2 today. Okay, so if 2 triangles are similar, you're going to see a pattern here. Alright, so we got the lengths of the corresponding angle bisectors. Now we have the length of the angle bisectors, okay? Angle bisectors, what do? Well, they cut the angle perfectly in half. They are proportional to the length of the corresponding sides. Alright, so we can, 2 semicircles, 1 semicircle, it cut that angle perfectly in half. Alright, next up. Theorems 3 and 4. Alright, if 2 triangles are similar, okay, the lengths of the corresponding medians, now a median goes from a vertice and cuts the opposite side perfectly in half, okay? Vertices, the opposite side in half perfectly. It's a median. Are proportional to the lengths of the corresponding sides. Okay, so we can use medians in our proportions. And then we have, this starts out a little different. All right, so an angle bisector, okay, we just talked about an angle bisector. Okay, angle bisector, it's going to bisect that angle perfectly. And a triangle separates the opposite side into 2 segments that are proportional to the lengths of the other 2 sides. There it is. All right. So let's do some math with this. All right, first up, we're going to talk about our medians. We're going to do the median one. Okay. We know we have our median because we go from a vertex and it splits the opposite side perfectly in half. Vertex splits the side perfectly in half. So we have our medians. Okay, of the whole triangle. All right, so it's the whole triangle that this is a median of. All right. So if it's the whole triangle, that means we need the whole side. And this whole side, well, if this is x, this is another x, so that's 2x. This whole side is 2x. All right, and this is the median of a whole triangle. Okay, so we need to use the whole side. So we have our median. Okay, it splits this side perfectly in half. This side is 12. That makes this side 12. That makes the whole side 24. All right. So we are going to set this up. I have a small triangle and I have a large triangle. Okay. We're going to call this the whole side. And then we have our medians. All right. When I am setting up my portion, I like to set them up like bivariant data. I like to label them so I get them in the correct location, because getting your proportions set up correctly, #1 challenge. All right. So now I'm going to do my small whole side. My small whole side, well, that's 2x. My large whole side is 24. Okay. My small median is 18. And my large median is 27. Once I set them up properly, it's just a matter of cross multiplying. So 2x times 27 is 54x. 18 times 24 is 432. And what is x? Well, x equals 8. Is that what it asked for? Yeah, it just wanted the value of x, so we found it. Okay? So it's very important. You need to distinguish if you are going for the whole side or whether you just need a part of it and you've broken this into 2 triangles. Okay, so for this, when we're using a median, the median is of the whole triangle, so we need the whole side. All right. Now, this one we're using the angle bisector. Okay, so we are separating this into 2 segments. We're separating this into 2 triangles. All right. Because we have our angle bisector. So we have the top triangle here, okay, and they happen to have a shared side, okay? They have a shared side. Well, from G to J is 12, all right? Then I have this bottom triangle, okay. Well, the whole side is x. G to J is 12. Well, to find J to H, you go x minus 12, okay. So, we've got a top triangle. We've got a bottom triangle. Okay, we have a shared side. Then we have the other side. And that is what we are given. Okay? So again, I set up my proportion like it's bivariant data, which is basically just 2 by 2 data. They are 2 separate things comparing 2 of the same original shape. So we've got the top shared side. Our top shared side is 12. The top other side is 30. The bottom shared side is x minus 12. And the bottom other side is 25. Alright, now that I have this set up properly, all that's a matter is of cross multiply. Twelve times 25 is 300. And then 30 times x is 30x. 30 times 12 is 360. Created a 2-step equation. So let's add 360 on both sides. 30x equals 660. And therefore x equals 22. And did it want us to find x? Yeah, it says find the value of x. So that's what we've found. Alright. this assignment seemed fairly straightforward for most students. If you do get stuck somewhere, make sure you ask. Chances are it is just an error, probably setting up your proportion. Okay. All right. Also, this assignment, I may have been distracted when I created it, and so therefore I didn't do it where you can, check your answer 3 times. So if you finish the assignment and you're like, ooh, I don't like that score, you can ask me, hey, Mrs. Burke, which ones I missed, and I'll look that up for you. All right. Thanks. Good luck.